Now consider second theorem, Stokes theorem. Okay, so we have studied divergence theorem. Now it is the Stokes theorem. So in the Stokes theorem, observe what is the region we have considered here. So region we have considered here is a surface, or we can say any finite surface is the region. Okay, then what should be the boundary? What is the boundary for any finite surface? Okay, for example, you consider any surface like this a square. Okay, so here this is the surface. What are the boundaries for this surface? So if I ask you boundaries for the surface, you are going to say there are four sides acting as a boundaries for the surface. Okay, so these four sides combinedly represents a closed path or open path. Yeah, exactly, it is a closed path. Okay, so closed path. Okay, so that means for any finite surface, boundary is a closed path. Okay, so not only for the surface, you consider any kind of surface. Is there another surface? So for this finite surface, what are the boundaries? You say that three sides of the surface are the boundaries. These three sides commonly represents a closed path. Okay, so maybe you can consider like a circular surface. So now what is the boundary for this finite surface? You can say that its boundary is its perimeter. So this is a circle. Okay, the circle acts as a boundary for the surface. Okay, the circle is a closed path. Okay, so like this you can observe that for any finite surface, boundary is nothing but a closed path. Okay, that's what we are going to write here. So region is a surface, then its boundary is nothing but a closed path. Closed path. Yeah. Now, so let me explain what is this meaning of this Stokes theorem with an example. So let us consider any finite surface, and the flux is moving from left side to right side through the surface. So this is the flux and this is the surface. Is the surface. Okay, so just by observing this diagram, we say that the flux is crossing the surface. The flux is crossing this surface. Okay, so I'm going to write the same statement. Flux crossing the surface. Flux crossing the surface. Okay, so is equal to what? So actually here also same as that of divergence theorem, Stokes theorem also gives alternative methods to find the same quantity. We have two methods to find the same quantity. Okay, so just by observing this diagram, and I will add one more flux line here. Okay, so just see here. So how many flux lines are crossing the surface? Here from the diagram you can count flux crossing the surface are 1, 2, 3. 3 flux lines are crossing this surface. Okay, so I'm going to write 3. Okay, so how do you say that these 3 are crossing this surface and this is not crossing the surface? So for that just consider this is the surface. For the surface, what are the boundaries? So 4 sides of the surface are boundaries. These are the boundaries of the surface. Okay, so the flux crossing the surface are flux inside its boundary. Isn't it? So I will write here flux crossing any surface is equal to flux inside its boundary. Or you may count here how many flux lines are inside its boundary. This is the boundary. How many flux are inside its boundary? 1, 2, 3. 3 flux lines are inside its boundary. Yeah. How many flux are crossing the surface? 1, 2, 3. 3 flux lines are crossing the surface. Okay. So same quantity flux crossing the surface can be found in two ways. One, directly we can find out how many flux are crossing the surface. Okay. Or we can count how many flux lines are inside its surface. There is also 3. Okay. So like this, Stokes theorem gives us alternative methods to find the same quantity. Okay. So this entire statement is written in the form of mathematical equation. So mathematical equation form for this statement is this equation. Okay. So left side we have a closed surface. Sorry, left side we have a surface. So that is equal to closed path integral. Okay. So this closed path integral is the boundary of the surface. Okay. So here I said that flux inside its boundary. What is the? It is a boundary of which region? Boundary for surface. Okay. So what is the boundary for any finite surface? Closed path. Closed path. Okay. So here we can equate surface to closed path. That's what we have written, surface to closed path equation. Okay. So this is the meaning of this statement is the meaning of this equation, or the statement is written in the mathematical form like this. Okay. So flux crossing the surface is equal to flux inside its closed path. Flux inside its closed path. Okay. Now let us write down this Stokes theorem in the form of a formula. Okay. So what will be the formula here? The formula will be surface integral of curl of vector A bar dot ds bar is equal to closed path integral of A bar dot ds bar. That's it. Okay. This is the formula for the Stokes theorem. Okay. So till now we have studied about divergence theorem and also Stokes theorem. Okay. So next we will see what is the theorem on gradient. Third important theorem on gradient.